Hello there, fellow human beings. My name is Kelvin Francium. I, being the state champion of quantum leaping, am here to present you the concept of electron configuration. It's fairly easy as long as you get an iron grip. Anyways, you have to know your orbitals. Each orbital on the atom has a different spin and numbers of electrons. There are the s, p, d, and f orbital. For each s has one spin, p has 3 spins, d has 5 spins, and f has 6 spins. On the chart, the f will only go to 5 because there are 7 s's, which refer to the spins. By multiplying the spins by 2, you get an electron count. Hence that S is 2, P is 6, D is 10, and F is 14. With the sections of the periodic table of elements, it is shown where the orbitals start and stop. This will be explained through examples I give you. Helium, for instance, is the first element of the first level. You start with the s orbital. This makes helium 1s1. The one in front of the s stands for the level. The one behind the stands for how many electrons in that specific orbital you have, or how far into the level you are. Next is neon, which is into the second p orbital. That makes neon 1s2, 2s2, 2p6. That explanation before about helium refers to this too, but the difference now is that since neon is the 6th in the p orbital, that makes it noble. A noble gas is an element that all the other elements want to be. An element that they look up to and in a noble gas configuration would be used to describe themselves. Such noble gas would be positive role model on society. Positive. Hey, hey, yo, noble gas is up in her. You're the noble gas? Yes, sir. My name is Lil Mama. I'll be the representative of Yo Neon Society. Anyone that wants to be a bright and poppin' wants to be me, 'cause, I mean, who wouldn't? But your grammar is atrocious. What you know about me? I is cool, and you boy needs to be stoppy. Alright, well, we'll call you back when needed, okay? That's right, you better. Right. Now, to show an example of so-called noble gas configurations, we shall use silicon. Hello! Oh. Wow. Okay. This silicone is Ne3S2 3P2, as explained. What about helium? It doesn't work as well. Why? Someone told me my head was full of it once. Sounds like fun. No, just stop. Dang, she even more stupider than me. Next is iron. This enters the D block. Iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Wow, my voice. It's only as 3d, so it all balances out in the end. Hard to explain, but you'll understand when you need it. Yes, arg. Copper is a peculiar element, being 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. 4s only has 1 because of the rule that there are no d9s or d4s. Lastly, we have California. This is where I'm come in a... Sure. Since Californium is in the F block, we have to find the part where F is inserted. This is right in front of 5D and 6D. Thus, Californium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4d6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f9. As you see there is a 4f and a 5f. Both have the count of electrons that are listed on the chart I gave you on the sheet. Is we done now? Well, I figured. Then let us lead our way towards this broad horizon of scintillating reveries turned into reality. It would be presumably swell to go visit the city of the angels and bask in the ambience of the elite. When did you develop this vocabulary? I told you, I was little mama. Expect it from me. Alright. Well, this is the end of the show of electron configurations. I hope you enjoyed it, and I'm just gonna go. Goodbye.